Okay, so we're starting convergence of series unit. First page of the part 1 notes. First of all, summarizing for what values of x these power series converge. So, and what do they converge to? These are in the first 3 are in your data booklet. Well, actually, I guess the first 4 technically, because that's a geometric series. So first one is equal to e to the x. Doesn't matter what x is, it converges. Same with the next one is sine x. Then the next one is cos x. Then the fourth one here, remember that's just a basic geometric series. So that converges for certain x values. Remember where the common ratio is between -1 and +1. So x is the common ratio in this case. Taking a look back up at these, just remember that n factorial, as n goes to infinity, increases at a faster rate than anything raised to the exponent n. So that's why it doesn't matter what x is in these 3. Okay, last one here, n factorial times x to the n. So again, they both go to infinity. It's not in a rational form, so that doesn't converge, except when x is 0, and that's what we're going to look at here in a sec. So that last one, let's look at it more closely and learn about the nth term test for divergence. So basically, if we look at what happens to the nth term as n goes to infinity, so we take the limit of that nth term. If it does not equal 0, then that means it diverges. Now the opposite is not necessarily true. We'll talk about that in a sec. But if it does not equal 0, then you know that it diverges. Okay, so that's something to be aware of. And so that case here, that's never going to be equal to 0. Except when x is 0. So for any non-zero value of x, this goes to infinity, so it diverges. Okay, so then, as I just said, the opposite is not true. If this were to equal 0, then oftentimes it does converge, but not necessarily. So how we say that is we say that there's a possibility that it will converge. And then basically we have to do some other tests. Okay. So here we need to use the nth term test for divergence. We're going to look at it a little bit closer in terms of different values of x. So x greater than or equal to 1, that's the same as x less than or equal to -1, x greater than or equal to 1. Okay, so that diverges. That's kind of like what you think about when you first look at that, that's series. Okay, then the next one is when x is between -1 and +1. So you can pause if you need time to copy this down or look at it. I'm trying to make the videos a little bit faster because I'm having trouble getting them to be uploaded to YouTube. So in any case, because that's a fraction or a decimal between -1 and +1, if I take the reciprocal of it, then that's going to be greater than or equal to 1. Okay, and then it's raised to the exponent n. So something greater than, that's not 1 to the n, but that's greater than 1 raised to the exponent n. N factorial will always grow faster than that. We talked about that before. So this, again, confirms that it diverges, because sometimes it's harder to think about when it's a fraction or a decimal, less than 1. And then x equals 0, well, that means that, okay, so converges only for the values of x equals 0. Okay, so let's look at that a little bit more. The series has met the first hurdle for convergence, but only if x equals 0. So write the first 3 terms. You can see, like, really, when are you going to create a series that has all terms 0? But the fact is that it does converge if x equals 0. So that's the radius of convergence for that particular series. If it's not 0, it doesn't converge. Okay, stay tuned for page 2.